seriously, gotta switch the bell. And start recording. Okay. Courses. Now, we pretend that I just came to class and this is a beautiful day and nothing went wrong. Okay. Okay, so this is me. I'm Fardad. I'm going to just go through. Today is good. It would have been only talk anyways. I hope I'm not going to put all you guys to sleep, but it's something that we have to go through, and I hope that I can go through it as quick as possible. I'm going to do the land acknowledgement when we have proper internet and stuff like that, not now. Most important thing, faculty information, office, and help. Okay? I don't have office hours, but I'm available all the time, which means by appointment. I don't put only 2 hours per week. I don't like that. Any time that you see I'm available, you can actually book an appointment with me. How do we do that? This is how it's done. Because for some reason, students keep forgetting this, I put it in detail now. Okay? So, and I'm saying, email this, not for subject-related communication. Please don't send me an email about anything about our subject. I'm going to reply to you after you graduated. So it's not going to be, okay? So I only communicate through MS Teams. Private messages through MS Teams, like that. I have my Teams open all the time. I can see and we can have a history of conversation. I don't have to go through 100 emails that is coming through to see what conversation we were talking about. With this, we have our conversation over there, and whenever we don't understand each other, we just click and we talk, okay? And please, try to talk to me. Typing is too slow. Chatting is too slow. If you see, I always say in my classes that respect the dot you see over here. There's this dot over here. If this dot is green or yellow, you can call me. Okay? As easy as that. Green or yellow, just call me. The other times you call me, definitely I'm not going to answer. But if it's green or yellow, either I'm just going to pick up or I'm going to come and see there's a missed call and I'm going to call you back. Number two, if you need to talk to me, use, and I put it, I didn't want to waste the class time. I actually created a video for it. So if you click over here on scheduling assistant that I'm insisting everybody to use, online only by appointment using. So you click over here. I had a video I once created to show students how to do it. So essentially, you go on new meeting to actually book an appointment with me. You go to calendar, you go on new meeting, and in new meeting, add the title, help with assignment, okay? Then required attendee is me, you put the name over there, then you click on scheduling assistant, then it shows all my availability. You can actually select where you want it to be, and you say save, and it sends it to me, and then I'll say either I accept or I decline because I have something to do, whatever. Please do it that way, and then we're going to be fine. Like that, we can have actually the communication going. I already added you to the 345 team. So I wrote the script and automatically added all you to. If you are not there, there's a code you can join in. Okay? If any of your friends wants to join the thing, you can give the code. I don't care. Okay? Anybody wants to join these teams, we're fine. It's very possible that I'm going to create another team joint with the other section that I'm teaching, so we are all on the same team, so we can all collaborate. But these two teams are created separately because I thought I'm just going to, when I create the meetings, I'm going to add everybody to that meeting, so you actually get an announcement coming from me that the class is starting. I don't know, maybe I made a mistake. It should have been only one, like all semesters. Anyways, so yeah, so please do so, and that's how my office hours work. And Believe me, it doesn't matter if it's 11 o'clock at night, 2 o'clock in the morning, I'm working, you see I'm green, just call me, okay? It doesn't matter. Like usually when I'm late working, I'm extremely bored and kind of a break when I'm talking to you guys. So, and the office, you know where the office is. It comes to the, brings up the same thing that we have, the team that you have in, and that's that. Online sessions, depending on what is the session. When I say over here emergency only, you have to come to the labs. I do all my tests and stuff in the lab, so your presence in the lab is mandatory. When I say emergency only, that's emergency for me, not you. Okay, so if something happens and I can't come, then I'll activate that. We go all online, and the online sessions are online. We know exactly what they are. We used to use Big Blue Button. I was really proud of that application, but apparently for all the cuts and stuff, we had to cut our relationship with them. Big Blue Button was a good thing because I could actually have polls and ask people and ask questions from everyone and see their participation. Teams, I can't do that. That's why, well, I'll tell you, when I tell you how to teach, I'm going to tell you why am I going to write an application for that. It's a small program for that. All in-class notes go to a repository that I have. This repository used to be in the organization of 345. Then, because of the notes that I put, other students talk to their profs about it, and we don't want that happen. But because of that, I put it in a private, not a private repository, in my own account in GitHub. When you go over there, that's going to be the repository. And as you see, the NEE section already has the first note over there. There's May07 was here like an hour ago. And you go over there, you're going to see the programs that I write. Anything I write goes directly on GitHub. You have access to it. You can exactly see how it works. Okay? So you don't need to take notes in class. I state this fact, and I sound like a broken record. I keep repeating myself. It's the third time, and hopefully this is the last time I'm going to mention it this semester. But it is proven by research that we have only one language processor. We have only one processor in our brain. We don't have 4 cores in our brain, or 10 cores. 1, not 2. Therefore, anything digital being done is just a distraction. So the screen that you have in front of you is nothing but distraction, proven by research. If you want to remember, don't close it, don't close it. I'm not saying to close it. It's proven that writing it with a pen and paper, even if you don't want to read it later, it actually gets committed to your memory because you're essentially listening. You're translating what am I telling you to your knowledge and back to muscle action. Therefore, you are actually processing the data to write. Therefore, you are writing it. Where typing is muscle memory. It's digital. Nothing gets committed to your memory. It's just a distraction. But if you're comfortable with it, by all means. One thing, I catch one person laughing at their screen, everybody loses the screen because I don't have time with that. When I say screen closed, I'm not going to say who did it. It means somebody was at the, and that's when I said screen's closed. Okay? So be aware of that. If I see you laughing, smiling at your screen, unless I wrote a very funny for loop. So, yeah, okay, please, okay? Another thing that happened in the other class, if you are to say something to someone, it better to be about the subject. And if that's the case, use your opera voice and talk to everyone. Okay? If you have conversation with somebody, it's not emergency, like, hold me, I'm dying. Okay? That's fine. But if you're like talking about what happened outside in class, that's disrespectful. Please either go outside to do it, or if it's something that is about the subject, share it with everyone. I know that many students do that, and I really appreciate it. Like when you don't understand, say, what did he say? I didn't understand that. I rather that be towards me. What did you say? So I can explain. Don't ask your friend, ask me. Okay? That's that. Workshops and practice are going to come up, but I have some disturbing news, which means you are to do an OOP345 workshop. I call it Workshop 0. Okay, Workshop 0, and I changed it. I put it in here. So if you look at in-class notes, at the beginning there is a Workshop 0. You see that? Forget it. I created a better one for OOP345 people, and it's on their site. So if you go to the 244 organization in workshops, they have a Workshop 0 now. And you go through that. It explains to you how to install Git on your computer, create a private repository on GitHub, ask your professor for their ID to collaborate, modify this, create SSH key, install Visual Studio or Xcode, clone your private repository on Matrix. If anybody asks me, I'm FTPing stuff to Matrix, I'm like, what, is it 1975? Like, who uses FTP now? Seriously, don't do that. Don't use FTP. FTP is like, holy, really? Okay, I'll explain. Quickly, I'm going to explain to you what Git and GitHub and all those good stuff are. We're going to go through this. So, and I'm going to give you a due date like for a week. So you have a week to do this, and I'll know that you have done it by receiving your collaboration request. And I asked one of the students in the other class to tell me. One of the students actually did it already. So I actually create something like this in here, and I put all your repository paths over there. And I want your repository to look like this. Okay? So I'm recording. I wasn't supposed to show all the guys' information, but anyways. So I want you to create a repository. OOP345 works. Your name, student number, email, and section in there. And this repository should be where you live and breathe 345 in. Anything you do, any test, little temporary program, anything you do must be done in this repository. I'll explain soon how. And that's very important. It gives you two things. Number one, did I close everything? No. The first thing that it gives you is knowledge of Git. Okay, and it's very important. And the second thing it gives you is immediate help and collaboration from me. If you need help with something, I'll explain how do I do the help thingy. And I'm sorry for those people who are from my 244 classes. It's redundant for them and they're falling asleep, but I have to mention it anyway. So how do we play the game in class? So those people are at home soon. You're going to have this happening to you. But what we have in class is a microphone. And whoever has the microphone is the next person who's answering the question. There are two things you can do. And when I create the program, microphone is going to go away. And your name is going to come up on the screen randomly. Okay? And that's going to be the person who's going to answer the next question. And it goes like that. And the questions are not to ridicule anyone. It's just to have two-way communication. And the reason is that when I ask the gentleman over here a question, if the gentleman doesn't know the question, subconsciously, all of you are thinking about the answer. Either I don't know the answer or try to think what it is. That process commits the answer when it comes to you into permanent memory, and it's extremely important. So whoever has the microphone has the choice. Either they can answer the question or they can simply say pass. When they say pass, it goes to the next person. Or if the person answers the question, it goes to the next person. And it keeps going like that in terms in class. People at home, I'm going to call your name. And that's why I say you need to have a microphone. I don't want chat type stuff happening. When I ask a question from somebody from home, you activate your microphone and you talk. Can you hear me?
Yeah.
One person is doing a thumb up instead of actually activate the microphone and say yes. Believe me, nobody's going to over here do anything.
Yes, sir.
Say, see, no one.
Hello?
Okay, that's not going to happen. You do that, I'm going to just like you get a headset. If you can't get a headset, come to class. You get a headset. You sit at your computer, you test your audio before you join the class with Teams. There is a test thingy that you can actually hear yourself, make sure everything works, and you come to class ready. You must be present in class. If you just want to listen, there is no point. Watch the recording later. Okay? I need you to be present in class, and it's extremely important. I appreciate it if you do that. So when the time comes and on the screen the name comes up, in class or at home, you will answer the question. And I'm going to it's going to be a nice attendance fee, so I'm going to do something. If you're not attending, I'm going to just hit a key so I know that you're not there, and it's going to keep track of people who are in class or not. For a study, I'm not going to do anything. For research to see what is that. Anyways. In-class notes. Workshops and practice are in a GitHub repository, in GitHub organization that you know. Course information, GitHub we mentioned. How to core. These are all redundant. So all the things that I have written over here was before I created that workshop. That workshop makes all these things not usable because you go through that workshop, everything's over here, everything over here will be known. You're going to have a midterm test, 4 quizzes, a final. You're going to have a weighted average between all these. Now, the reason that I said I want to bring up SYL over here. Let me see if I can actually bring it. Seriously, Bell is doing amazing. OOP345. Summer search. RDAD. Draft. It means, I'll tell you why. So what happened over here was, let me just see if they fixed it. One, two, three, four, five. No, they didn't. Okay. So the reason that it didn't go through it was that for some reason there was some bug, and the last 2 weeks of the semester were, so it didn't go through. I'm going to go through it with you. And when it becomes available, I'll let you know so you can actually go over there and read it in detail. So again, office stuff we talked about. It's flex mode, you know that. Time and location, you're here, so you know. Okay. Learning outcomes we'll go through. Those are the things that is not important. The material that you want, the reference material that you want to read, they're the exact same thing in our ORI, exactly like OOP244. There is a site for that you go, and all the information is there. Anything that we are going to do. The first, for the introduction, these 3 things that you see are for the first week, so please go through them. OOP345, unlike OOP244, I try to cover all the material that I can, but it's impossible. So I'll go through it as much as I can, and I point to the things that I find important, but you are responsible to study all of them, and the next day come and ask questions. It was that over there that I didn't understand. Can you explain it? Okay? Extremely important to do so. So you have to study. I'm so sorry. Okay? Number 2. If you miss 1 week, you can catch up. If you miss 2 weeks, you can work hard and catch up. If you miss 3 weeks, drop the subject. Okay? You cannot catch up. It is extremely important to start now. And if you feel that there is problem and there is something happening and you need help, come to me early. Don't let it be, I'm not going to be here after midterm. Don't go ask your next prof a week after the thing that I have problem with this and that. Don't do that. If you have any problem understanding this stuff, we are getting paid to teach you. Suck the information out of me. Don't wait over there for me to teach you. You follow what I'm saying? You have paid for this. You are obligated to force me to teach you. So do that. If you feel you're falling behind and you don't understand certain things, bug me. Don't care if I get angry if you ask a question 50 times. It doesn't matter. It's my job. I'm getting paid for this. So do it. please, okay? And I beg you, if you have any problem, act quickly and early. Don't let it stay, because it will be too late. And you won't be able to, like, I see people genuinely coming to me after midterm telling me, what can I do? And I'm like, I don't know. Like, I can't. It's not possible, okay? But if you start from the beginning, I'm telling you, it's an easy course. It's not difficult, really. Okay, so go through these things, and then we're going to be fine. Sorry for all these preaching at the beginning. I hate the first session that I have to do, but I have to clear these things up and talking about all these things. So that's that. I think we're good. Now, what is Git? Who knows what's Linux? Anybody knows what's Linux? Anyone? What's Linux?
Operating system adjacent to Windows.
So pass it. Oh, give it to the gentleman behind you. What is so significant about Linux? What is a big hoopla about Linux? Do you know?
It's more efficient than the other operating system.
Give it to the next person. Why? Why it's more efficient? Why it's installed in the majority of devices?
It's open source.
It's open source. That's a big hoopla. It's open source. You don't have to pay for it. Okay? And it's built by all the geeks that writes the viruses in the world. So there is no virus on Linux. Okay? Because the people who are writing the virus are the people who are debugging Linux. So that's the case. It is that way. So it's made and built by geeks. It's the biggest open source project in the world. It's the largest one. And do you know who made it?
No.
Linus. Who can pronounce his last name? Torvald? Linus Torvald? Yeah. I never. 50 times. Oh, by the way, I suck at remembering names. I apologize for that. I'm going to murder your names. I know. I'm really sorry. That's why I don't expect anybody to tell my name, right? So you can murder my name as much as you want. Well, I'm so sorry about that. I remember faces forever, but I cannot remember names. So I apologize for that. Anyways, so this guy, Linus, created Linux in his garage basement on his computer. Genius guy, okay? And made it open source so everybody can contribute. And it boomed. And it became the biggest thing that is out there, one of the most efficient operating systems that we have out there. But the amount of contributions went so much, too much, that it was not possible to be able to handle all the contributions. Just imagine you have one file and 900 people are working on one file. How can you manage that? It's impossible. So what did it do? It created Git. So Linus created Git. What is Git? Git is essentially a version control system. What does it do? Have you seen that thing says Big Brother's always watching? Okay, that's exactly what it does. So what you do, you have a directory, a folder on your computer. Git converts that folder to what we call a repository, which essentially you can tell to Git, watch these files. So you flag certain files that are important for you, and you tell to Git to look, to watch these. And as you are working on them, you keep taking snapshots of the status of your development. So you start it, you take a snapshot, and it says start of the project. And then you work, you get to a certain point, then you take another snapshot and you name it. You take another snapshot, and each snapshot that you're taking, you can come back to later on. You can even undo to that snapshot, each snapshot. And not only that, what is genius about Git is that it's a distributed system. What does it mean? It means the folder that you change to a repository, you can copy it on another computer. This is called cloning. So you literally copy your repository somewhere else. Now you can push your changes to that repository or pull the changes from that repository. This push and pull we call it a smart upload and download, actually. So when you push, it doesn't upload the whole damn thing. It only uploads changes that you made. And a beautiful thing about it is that each repository is literally as a clone. So when you take 50 snapshots, these snapshots are called commits. So you say, I'm committing. So when you're actually writing the code, you commit, and then you write the code, you commit, and each commit has a label. Going to lunch, commit. Then you come back, continue. Going to washroom, commit. You come back, you go. And then you come back after the washroom, you write code, and you screw things up. Shoot! What did I do? It was working when I went to washroom. You're going to say, okay, show me the differences from the time that I was in washroom and now. It brings the two up, shows left and right, so you can exactly see what was changed. And if you can't fix it, you can simply say undo to that moment. And all these actions that you are doing on your own, after 200 different commits and push and pulls and changes, you can simply say, push all these things to another repository. It pushes everything to another repository, and all the history of your work, everything that you have done, will be copied to the other one. That's Git. And no, this is like the minimum thing that Git can do. No one knows all depths of Git. It's such a powerful thing. You can, I don't want to confuse you, but you can do many things with it. But what I just told you is the first 3 commands that you learn. So what I want you to do is this. You're going to go in a, so there was this company. The company said, okay, all these Git repositories, I can actually have a Git repository on my home, at home, have its IP address, come over here and clone the repository on my computer over here. I can push it to home. So I can do it like that. It's very easy, okay? But it's not reliable. It's home, right? Maybe something goes wrong and it dies, like like my hard drive gets fried and stuff like that. So there was this company. This company said, we're going to create this farm of computers and create a cloud, and we're going to hold all the instances of everyone that have Git repository. We're going to hold a copy of their instances in our company. So it's reliable and you're not going to lose it. They call that GitHub. So GitHub is essential, and there are many other different companies that, and GitHub was open source too. So there are other companies to do the same thing too, but GitHub is the first one that came out, and then Microsoft bought it. So anyways, so GitHub is the place. So that's the process that I want you to actually take. So in that Workshop 0, I'm going to send you an announcement for it and my expectations of what you need to do. You don't need to do everything that OOP345 people are doing, but you're going to do most of the stuff that are needed. So the very first step that you're going to do to go to Apple is, if you have an Apple, go to Apple instructions. Apple people, sorry, Apple is against my religion. I hate that company. It's like, seriously, I'm so sorry, I'm so sorry, I'm so sorry, I'm so sorry. Everybody has Apple in this class. Anyways, yeah, so I don't like the company. They're bullies. I don't like it. Like, if you want to write an application on Apple, you have to pay them. You have to pay them to write an application to run. What the heck? I don't like it. Anyways, it's something like that. Yeah. But it's a beautiful operating system. It is actually Linux. Apple is actually Linux. So all the stuff that we have over here, those people who have Apple, go to Apple instructions. Your instructions, steps that you are taking is much smaller than, much less than the Windows people. But you have to kind of be geeky. So everything for you is going to be command line. But the Windows people are going to do this with their mouse. Okay? So PuTTY installation is for Windows people. Git installation is for Windows people. Apple people, when you install Xcode, Git comes with it. So you don't need to do that. Okay? That's that. GitHub setup is for everyone. So you're going to create a GitHub account. I want your GitHub. If you have a GitHub account in Seneca organization, I don't want that. I want your own private account with your own private email. I don't want Seneca email. Why do I want this? I want you to be visible in internet. When you want to go look for a job, they're going to Google your name. If your private GitHub account comes up and they see you've been active since 2025 and you have done this many contributions, you will literally receive badges. The more you work, the more push and pull you do, the more cloning you do, the more forking you do, you get badges on GitHub. Those badges are reputation. When I wanted to hire somebody for my research at Seneca, I would Google their name. They had a GitHub account, I would interview that person. If somebody would want to come to work and they didn't have a GitHub account, that's not a programmer to me. That's a person who doesn't know how to collaborate. Why do I want that? Right? Nobody wants. The most genius person in the world, if they cannot share their ideas, it's worth nothing. So, create the GitHub account. Everything comes with a tutorial video. So I explain, and you click over here, 1, do this, 2, do that. So I literally show you how everything works, okay? Update your GitHub profile. You can create a GitHub account, but put your real name in there, okay? Put your real name. And something that I forgot to mention to the other classes. If you have an account already, good. If you don't have an account and you're creating a new one, please choose a proper user ID. Always mention, cat killer, not a very good name when you want to become a CEO of a company. Okay? Don't do that. Or I hate this. Don't do that. Put something, look at yourself as a person who's going to be a respected member of a company. What do you think that the user ID of that person is going to be? Choose that, okay? Cool dude is fine. Beautiful lady is fine. Stuff like this are okay, but again. So after update your profile with all the good stuff that you have. If you want your Seneca email, you can always add it as a secondary email. You can have 50 emails over here. You can add it as a second, but your primary email, make it your own to make sure that you can add me as a collaborator. If you go to Seneca, because my account is not in Seneca, you cannot add me as a collaborator. Create a private repository, and I cannot put more emphasis on the word private over here. If you don't make it private and somebody pick up your code from there without you knowing and submit it, you're going to be charged with plagiarism, even if you don't know if they have done it. You don't know that you have done that. Your code is open to public, makes you guilty. You don't have to take part in plagiarism to plagiarize. Just it's as if anyways, lock your door, okay? Make it private. When you are creating it, I'm asking what you put in there, so it's going to be all there, and the tutorial video is there again. Git ignore file is an extremely important file. As you see, it says .gitignore. Is an extremely important file that you have to add it to your repository. Not only adding, but then after you add it, go to any of the repositories that I have in OOP345 website and copy the content of the git ignore in there into your own. Again, tutorial video is over there. It explains to you. Why? Git ignore ignores files that are not needed to be pushed up and down. Okay? So when you're compiling your code, you have a code, it compiles, it creates object files, it creates executables, lots of garbage gets created over there that you don't need. When you do a push, it looks to see what it should get ignored and ignores those things and passes through. Many of you have overquotas, become overquota in Matrix. So my account doesn't work. Why? Because it's full. Why? Because you kept FTPing the whole damn thing over there, and your account got filled with executables that are even for Windows. That's nothing to do. So with that, it's never going to happen. Okay, so do that. Git ignore file is extremely important. Go through that. Tortoise Git is extremely important for Windows people. With Tortoise Git, you don't have to you don't have to type anything. You just go through the installation, and it's done. SSH key. What is SSH key? Do you know what's an SSH key?
No.
Anybody knows what is an SSH key?
Yes, it's like you don't have to enter your password when you connect to.
Yeah. So Side effect of it is that you don't have to enter your password, but isn't that risky? I'll explain exactly what an SSH key is. An SSH key has two parts, private part, public part. Private part of the SSH key is literally like a key that you have to the door to your apartment. That key that you put in your pocket, that's the private SSH key. The lock on the door of your apartment is a public SSH key. Everybody have access to it, but only those with the private SSH key that matches that one can open the door. Does that make sense to everyone? That's what you do with creating an SSH key. You create a two-part SSH key, private and public. You keep the private one on your computer. You put the public one in GitHub. Now, when you want to communicate with GitHub, it sends automatically the private key to GitHub. GitHub matches it to the public key. Match lets you come in. You don't have to put password in it. Now, if your computer is password protected and safe, just do as what we said. But if you are on Matrix, it's a good idea to put what we call a passphrase on your private key, which means if somebody goes to your Matrix account, picks up your private key, they can access your GitHub, right? So that passphrase, don't put something complicated. Put something very simple, because if you forget the passphrase, there is no I forgot password for a SSH key. You have to delete the key and create another one. It's very, very, it's a painful process to go through. So put something simple. Not 1, 2, 3, but put, I don't know, 2, 4, 6. Something. Put something, very simple passphrase, just for an ordinary person won't be able to find, to log into it. But again, you're studying, like if I get your SSH key, what am I going to do with it? Like what your for loop is going to do to me. So, you know, so for now, maybe a passphrase on Matrix is an overkill, but if you want to practice, there's no problem, do it. So you can create SSH key on Windows using PuttyGen. PuttyGen comes with Putty, the terminal client. You install PuttyGen, comes in, and it creates a key for you in a very easy way. Tutorial video is over there. Tells you exactly how to do it. Creating SSH key on Matrix is exactly the same thing on Apple. So they are the exact same thing. The difference is that over here, you have to first open an SSH connection to Matrix, then do this stuff. On your Mac, you open your terminal and do it, because you're on it right now. Okay? So the process of how to do it, I have written the stuff that you're supposed to do, but again, it's in a tutorial video too. It explains exactly what it is. You create the SSH key, and so essentially you create an SSH key, you run the SSH agent, you add your key to the agent, and the key will be used. So when you talk to GitHub, it's going to be used. But that thing is only for your session. To make sure that every time you log in, you have access to your SSH key, it's better to add it to your .profile, .bash profile. Who knows what is .bash profile? No one? You're in third semester? Shame. Okay, .bash profile from first semester in your Linux, it's a file that whatever command you put in it, when you start your session, it runs automatically. So when you put these two lines in your .bash profile, every single time you log in, it runs the SSH agent, loads your key, so you don't have to do it every single time. Okay? Now, the only difference for Apple people and Matrix people is that Matrix has a bash shell. Your Mac, can you open up your terminal and tell me what does it say at the top? Oh, it's off? OK. Anybody who has a computer on, open up your terminal. See at the middle, at the top, what does it say? In a term. At the top of the window of the terminal, it should say something. You see, it says ZSH. That means you have a ZSH shell. If it says bash, it means you have a bash shell. Okay? The only difference between Matrix and your Mac is that the name of .bash profile in ZSH. Shell is .z profile. That's all. Everything else is the same. So you do all these things on your computer, on your Mac, by all means do it. But when you are creating .bash profile, create .zh profile. But everything else is the same. You clone your private repository on your computer using tortoise-git, and you go on Apple. You do it using command line. Now, when you are working on Matrix or Apple computers, because you have to do everything manually, okay, the process using tortoise-git is very simple. When you want to commit and send stuff to GitHub, it's just a right-click on a thing, and you click on commit, and you just write a comment in the dialog, and you say push, and it goes, and our life is beautiful. In Matrix, to actually do that, you have to first stage your changes, which is an add command. You have to add the changes. Then you have to commit the changes with a comment. Then you have to push. Therefore, I created this thing for you, and I said put it in a file called push all. You see that? Push all. And do these things. It's in a tutorial video thing, everything, so you just follow the instructions. You do all, you add this thing to a file. So when you are pulling, that's easy. You say git pull, it pulls everything. There is nothing to add or remove. When you clone, it's easy. You say get clone, and you put the path, it clones. But when you want to add, commit, and push, you simply say push all, and you put the comment in front of it. It first adds everything, then it commits. I don't want to explain what those options do, but it commits generally and adds your comment after that and pushes everything to GitHub in one shot. So it makes your life easy. OK? That's that. Install Visual Studio on your PC. For Windows people, you install Visual Studio. Most of you should have Visual Studio, I think, by now. Okay, soon we're not going to have it because students are using something else in IPC 144. Anyways, but for Apple thingy is the same thing. So first you create a GitHub, then you install Xcode, everything else comes with it, and life is beautiful. At the end, this is what I'm going to ask you to do. So you're not going to go through the submission. All I need to do is to get that email from you that you added me as a collaborator. So let me see. I hope that I'm going to have one over here. Yes, I have 5 of them. There you go. You see these? That's what I want. When I click over here, it shows me the invitation. I click on the invitation and accept invitation. I am a collaborator to that account. And I have, see, that's a 345. So that's what they created. I'm not going to see if they've done it right or not. But that's the thing. There you go. It's as easy as that. As soon as I get that, it's fine. So when you do that, you're fine. You don't need to do anything extra. Let me see how they did it. Yes, very nicely done. OK, and that's it. Now, I'm going to end the GitHub thingy with one thing. OK? And I want you to kind of remember this. And I always say it this way. I'm going to say take a piece of paper, write these 3 words, and stick it to the ceiling right above your bed so when you wake up, you see it every morning. OK? This is the process that you do when you are writing, when you're developing real application in real world. OK? When you want to start work, 3 steps are totally what your work is supposed to do. 3 steps. Step number 1, pull. So before you start anything, doing anything, you go to your, first of all, everything is done in a repository. You don't create a temporary folder somewhere else, do it, and then bring it to the repository. Never do that. Everything, all your temporary directories, all that junk stuff that you want to do, anything you want to do, put it in your repository. Don't have any other directory. Your repository is where you're working. You want to start working, you just open your computer. Let me work a little on OP345. The first thing you do a pull. That's number one. Number two, you start working. Okay? Anytime you want to go, you commit. That's all. And then when it's end, you commit and push. But because our commit and push is combined, then it's as easy as that. You pull, commit and push. Pull, commit and push. You never, ever start working and then push. Why? Because your they call it upstream. Upstream means GitHub. Your upstream may have work that you did not pull. If you change something that is changed over there too, and you want to push, then it's going to push to something that is one step ahead of you. That's what we call a conflict. Okay? You can, Git is designed, you can easily fix that conflict, but we don't want that conflict to happen. But if you pull, it means first you get the latest version, now you're working on it. When you push, you're ahead. Everything's going to be fine. So always start your work with a pull, and you're fine. If you face a conflict, try fix it. If not, contact me. I'll tell you how to fix it. Okay? Conflict is always happen. You know when conflict happens? It's when you do your work, and you pushed last time, and you know that you didn't do anything. So why am I pulling? I didn't do anything, right? But you're not aware that I looked at your repository and I saw something over there and I just wrote a comment over there for you. Hey, I was here looking at your work and you did this and that and I just pushed it. Because you didn't pull, you didn't get something that I wrote over there. Therefore, conflict happens. Okay? So always pull first. You never know. And especially if you are working as a group with friends on a project or whatever you have, this pull thingy is magic. Okay? Always. All right? That's that. So always pull before you do anything. And that's that. That's about Git. Questions? Suggestions? Objections? Okay. Now, let's let the preaching continue. Are we good at home or online? Anybody has a voice over there? Can somebody say hello and make me happy?
Hello.
No?
Hello.
Maybe it might. Wait a minute. Maybe my audio is disconnected. Say hello again. No? Is it that difficult to unmute and talk? Anyone?
Hello.
Ah, Basil. Okay, 1% for midterm. Okay, good.
Hello.
All right, good. Now I can hear everybody. Good, good, good. All right. Okay, nice. Okay. So that's that. So we talked about how to make an appointment, office hours. Yeah. I ask a question I'm extremely serious about it, and people at home, please don't type in chat and talk to me if you want to answer this question. This is an important question that I want to ask. What a professor should do to be a good professor for you? Like what thing you think your professor should have to say, oh, that was a good teacher. I had a good teacher. I want that. I want that. Think about it. Like you let it sit for 15 seconds. What did your past professor do that sucked and say, I hate that guy. I want you to tell me not to do that. And it's not an empty promise. I really try. So that's something that I need to know. People at home? Are you there?
I can tell what I liked about my prof.
Oh, you liked? Okay, that's good too.
Yes. So I had last semester as an OOP,
Mm-hmm.
and I think my friend Evan had him too. And what I liked about this particular prof is that whatever is on the lecture, like if you are on the lecture and you're taking notes and you study honestly and you come for the quiz, everything, like there's no surprises for you.
All right.
Because sometimes there are surprises. For example, I had a web teacher, a prof,
Mm-hmm.
and every single time I would have a test, like 20% would be like
Surprising.
completely missed out.
Okay, I have good news for that. I tell you what the questions are the day before. So you know what the questions are the day before. It's me. Oh, and one more thing. Please don't go tell to the next prof, like, Fardat did it that way. Why don't you? Don't do that. Okay, so I tell you what the questions are. Listen, no, I'm not going to tell you exactly what the questions are, but I'm going to tell you the next time that you're coming in, you're going to write a move constructor, a move assignment, check the rule of 5, and write a smart pointer for me. That's what's going to be. So no surprises in that thing. And which brings us to how the tests are done. The tests are all done on a computer. You never do it on a paper. When you're doing it on a computer, I'll block all your computers in a way that you only have access to your test and Notepad++. And I follow that to the bone. And that's one of the bad I don't know, bad features of me. I don't know what you call it. Bad things that I want that makes me a bad prof is that I have I do not mark a question that is not well written. Well written is that after when you're in third semester, if you don't know how to indent your code, you better not be here. Okay? I give you Notepad++. As soon as you start your test, you start your Notepad++, you save your Notepad++ as .cpp. Then it's going to give you IntelliSense. When you actually type, it completes your thing. It indents everything. It syntax highlights everything for you. If I get a flat code that is coming like that, I'm not going to even mark it. And I'm going to tell, and all these things again, I'll give you a video, I'll give you a practice test. You're going to do a practice test so you know exactly how it works, no surprises. You'll see exactly how you're supposed to do it. You open up your test. You open up the answer place for your test. You open up Notepad++. You answer the questions, and I'm monitoring you on a computer. If I see you are doing something wrong, I'm going to call your name and your ID, and I'm going to come to you and fix your thing. I'll do that. You'll see. After you're comfortable or you get to a certain point, you copy everything. You paste it over there as code snippet. Again, how it's done, it's all visual. I'll give you a video so you'll see. And I'll give you 2 weeks in advance to practice so it becomes just a normal thing for you. So you come, you log in with your cell phone. All the cell phones go to the edge of the table. All the smartwatches goes to the end of the table. No reference sheets whatsoever. You're not allowed to bring anything but your brain to the computer in front of you, because I'll tell you what the questions are. Okay? Then you open up the test, open up Notepad++, put it side by side, write, paste, save, submit, and you're done. Concept questions maybe only in midterm. Everything's programming. So you have 2 tests with 2 quizzes with me. They are going to be both programming. You're going to write 2 programs for me to see, and I'll get you with that. And I'll get your knowledge with that. And that's that. That's it. We okay with that? Okay, next thing. What else? Anyone? We're good? Okay. People online, we're good? Anything you need to say? Nope?
Yes, sir.
Go ahead, what's up? Oh, yes, there was, you have nothing to say, or? Somebody's on hold. Did I do it? Oh no, I think he's gone. I don't know what does this mean. I don't know if I did it or that person did it. I don't know. But anyways, I hope I didn't put somebody on hold. I have never used Teams for this. I used to use Big Blue Button, not this one, but this is, yeah, new thing for me, but we'll see. Okay, so we're good down to this point. Anything else you want to know before we do a little bit of talk of Object orientation and start of the C++ thing. Suggestions? Questions? Suggestions? Objections? We're good? All right. Okay. As I always say, first Earth got cold, and dinosaurs came, ate too much, and they died, and then the programmers came. And they started writing code, structured code, reuse their code with functions and stuff. It became too complicated. They said, we cannot think like this. We have to make our code look like what we do in real life. So they gave all the features that we have in real life to the code, which is essentially object orientation. They said, we're going to treat everything as objects as we have in real life. If I tell a cell phone, everybody knows what a cell phone is. They don't know what is the build of it, but they know what they do. If I say bottle, water bottle, or a bottle, or a thermos, everybody knows. When I say thermos, it keeps something cold or warm. They know it. I don't need to mention it. It knows. So it could be that one, or it could be that one. When I say coffee cup, these two are identical, but I have some over here. There you go. These are both coffee cups, different features, but they do the same thing. Mine actually has tea in it. So that's object orientation. And now to make this thing happen, they actually try to create a series of rules that the minimum requirement for something to be able to simulate what we have in real world. And what is that called? When you look for things, when you have a problem in hand, you look at the problem in hand, and you want to fix that problem. You look at the problem and you only pick the parts that is important for you and ignore the rest. I always tell in class, I can salsa. You care? No, not salsa, but nachos. I mean, like, I can dance salsa. But you don't care because I'm a teacher. What is important for you? Me teaching C++. If I teach geography, you don't give rats behind. You need C++. What is that called? Abstraction. So you apply abstraction. Without applying abstraction, programming is impossible. Any program in hand, any problem in hand, you look at what you need to do, you only take care of that, and you ignore the rest. If you don't master this, you're going to be one of those people who keep writing the program and is never satisfied with the work done. Because you say, I'm going to add this too. I'm going to add this too. And sadly, I used to be one of those, and I'm still sometimes comes out, and I keep doing it, and I see I did it too much. It happens. Okay, so abstraction. So to be able to, they applied abstraction to real world, and they came up with 3 major rules for object orientation. And the first of these 3 rules, or one of these 3 rules, is encapsulation. So what is encapsulation, my lady? Do you remember? Oh, by the way, remember the rule. If you don't know, if you're not in a mood, you don't want to talk, you simply say pass, and I'll go to the next person, okay? So remember what encapsulation was? No? Okay, encapsulation?
It's like you hide the attributes from the client code.
Information hiding. Yeah. Hiding the attributes from, but that's not the only thing. Actually, encapsulation actually doesn't mean that at all. That's one of the side effects of encapsulation. What is encapsulation?
Like putting the related stuff into one object.
We are getting close. Putting the related stuff in one. So far, I see that you guys actually kind of know what's going on. I'm happy. Okay? But the problem is that none of these will actually get you the job yet. What do you think, my friend?
I was about to say what he told.
Okay, how about you? What is encapsulation? Same thing that he told. No, 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 no. What is encapsulation? It's the same thing he said. Encapsulation. Do you remember what encapsulation was?
Yeah, like class.
Yeah, encapsulation. We created a class to encapsulate things. Okay. So far we went with hiding stuff, putting stuff that is what we all have stuff, hiding stuff, putting stuff that is related together. Same thing that this guy said. Same thing that that guy said. Same thing. So what is it really? Yes, but you're talking C++. I'm asking object orientation. If you come to my 11-year-old girl and say, we put attributes and methods to you, what the heck are you talking about? You're getting close. I'm not going to let you tell. I'm forcing people to think. Relative data and logic.
So we hide the logic inside, but we suggest
That side effect.
outside tools to manipulate this logic without seeing what's inside.
Yeah, but you see, you all know what's going on. Okay? The only thing that you have to say is this. You put the attributes and behavior together. That's it. Data and behavior together. If you put data and behavior together, you're encapsulating. Okay? What is the difference between a dead body and a live body? They are both human beings. If I'm here standing or I'm dead on this table, what is the difference between me and that guy? That one is C, I am C++. C is a structure with all the attributes. You see, legs, face, everything. But the guy doesn't breathe. It doesn't have any actions in it. You follow what I'm saying? If you don't put the behavior in that class, that's C language. Everything's dead. It's like you have to animate it like those. What are those guys that do this? They call it puppeteers? Puppeteers are C language. C++ is robot. Puppeteers are like there are dolls over here with strings and somebody's moving it. And if they want to move another one, they have to put it down, pick another one. Because these dolls don't know how to move by themselves. Robots move themselves. They know what to do. You tell to this robot to go there, that one go there. They're going to go. That's object orientation. Putting the data and behavior together. We clear on that? Okay. So we covered encapsulation. What is the next one? So polymorphism inheritance. This doing you. Do you remember what is polymorphism? And you can pass it along.
Like having functions of like a single function but with different.
Yeah, you're saying it, but again, I want you to give me interview answer, okay? When you're asking somebody what is encapsulation, you're going to be putting the data and behavior together and hide the things that are not needed to be. So information hiding is actually a side effect of encapsulation. It's not encapsulation. Encapsulate essentially means putting two things in capsule. If you think, okay. So what is polymorphism? Remember? Different shapes and forms of what? Different behaviors that, you're right, but how do we, what does it mean, polymorphism? You remember? It's very important.
Like having, like using a single kind of like object to represent like different types. Like they're all kind of the same thing, but.
That's instantiation. I can have I can have a class and create 5 different objects of the same thing. That's instantiation. But you're getting it. Do you remember what it was? Anyone? You can see who's a coder and who's gonna. You wanna be a programmer? You wanna be an analyst one day? Give me the answer for analysts. Polymorphism. Poly, what does it mean, poly? What does it mean, morph? Polymorph. Morph means change forms, right? Polymorphism, many shapes, many different shapes. Doing the same thing in different ways is polymorphism. Airplane flies, pigeon flies, mosquito flies, helicopter flies, kite flies. They all fly, but in a different way. Right? We good? Okay. Oh, I know, boring part, but I need you guys to know these things before we continue. And the last one, inheritance. Open discussion. I think people at home are probably, I don't know, they're just there for, anybody wants to chip in at home? I have 2 screens. Wow, lots of people at home. Oh, only 2 more. Okay. Anyone at home? Inheritance? What is inheritance, people? You guys talked enough.
Another class can get some of the features from the parent class.
Fantastic. Another class can guess the feature. Again, everybody knows, but you are knowing because you wrote C++ code. Okay, inheritance is reusing design. That's all. You reuse your design with inheritance. You have a motorcycle. You're at a place that people only have cars and bicycles, and they have nothing else other than cars and bicycles. How do you explain what a motorcycle is? You say it's a bicycle that, it is a bicycle that has an engine. That's reusing design. When you say it's a bicycle, they know everything about a bicycle. You put an engine on it, it says no more pedaling, and it becomes a motorcycle. So essentially, inheritance is reusing design. Okay? Hence, we are having a class, we created a class, and everything that we do comes out of that one. Are we good? All right. 5:05, we have to, oh, I didn't give you guys a break. You want to go for 15 minutes, go 5 minutes early, or go 5 minutes break and come back? 5 minutes break is never 5 minutes. I know you're going to go and never come back. Okay. So I'll bring one thing up. Before we go, and the next day you're coming in, we're going to actually, okay, the lab that you're going to come to, okay, if you started the installation stuff from workshop 0 of 244, and if you hit the wall and you have a problem, bring your computer so we can fix it together, okay? That's number 1. And number 2, we're going to have lecture in the lab, okay? Labs are going to have lecture. You have only 4 assignments, and yeah. Anyways, labs are going to be mostly lectures. Be careful. You have to be there. I'm just going to talk about the compilers, and then we're going to go. How does the compiler work? This is something from OOP345 I created 9 years ago, and I always say, I'm going to make it better. I'm going to make it better. And it stays the same ugly thing that it was 20 years ago. Okay. Usually when you write a program, when you write an application, you have multiple files, right? I'm too heavy. I'm going to bring up, oh, I cannot say. I'm afraid that's going to break. And his notebook is going to, okay, so I'm going to sit here, safe. Okay, so don't worry. So when you write a program, it never happens that you have only one file. You have several files that you're writing and compiling them together. So you're essentially saying, I'm compiling my program. But when you're compiling your program, compiler does not work the same way that you think. When you actually compile a code that has 4 files, in this case, 1.cpp, 2.cpp, 3.cpp, and 4.cpp, the files that I have over here, if I run the compiler to compile these things, hence writing G++ 1.cpp space 2.cpp and write it like that and hit it, I'm not running the compiler once. The compiler will run 4 times. 4 independent times. And each pass that it does for a class, for a file, is not aware that other passes happen, which means when 1.cpp is being compiled, it has no idea that there's a 2.cpp. Even when 3.cpp is compiled and the header file of 2cpp is included over there, it has no idea that 2cpp exists. It just trusts your promises. What are your promises? Your promises are all the prototypes that you put in the header files. In a header file, you put definition of a class, declaration of a class. You declare a class and all its methods. You put function prototypes, things like that. So you're essentially telling to the compiler, hey, I promise there's going to be a function that this is the signature. So when you see a function call, translate the function call, not the function. The function itself is not there. It's as if I tell you, if you have problem, go talk to a tutor. Am I actually taking a tutor and give it to you and say, go to this? No. I'm just going to say tutor. And you're going to say, where is the tutor? I'm going to say, it's down in Learning Center. That's the header file of Learning Center is being included in my speech. So the Learning Center itself is not compiled at the time. And when every individual thing is compiled at the end, then all get packed together, and the compiler calls the fifth program, which is a linker. The linker actually checks to see if promises you made are actually kept in other files or not. So I'm going to the test center, and I'm compiling to the test center. In test center, I'm telling to the tutor, when a student comes, help the person. It doesn't know what is a student. It just knows it's something that it has to help. The student itself is not present at the moment. When I'm talking to the student, and I'm going to say, when you are going to the test learning center, talk to the tutor. The student doesn't see a tutor. It just knows it's supposed to be there. The linker actually does that. The linker checks. This student needs a tutor. Do I have a tutor in the learning center? If that's the case, compilation is successful. But when compiler compiles and you say, go to the learning center and see a tutor, compiler checks the learning center, no tutor, it's going to give you a compiler or say the function you called doesn't exist anywhere. Okay? That's the stages of compilation that happens. Back to back for something to happen. So when linker runs and doesn't give you an error, there is only one guarantee and only one guarantee that your syntax and grammar was correct. It has nothing to do with your logic. It has nothing to do with if the application is working properly or not. Okay? So these things that happen inside for syntax, these are compiler. When promises made are not kept, that's linker error. But in short, we call all these things compilers. After the compilation is successful, when the program is running, that's what we call runtime error or runtime. In runtime, there are two reasons that your application might not work. The most common ones, logic error, which means you just said something. I'm just going to say, microphone is coffee ceiling me. I put 5 different things back together, and individually they make sense, but together it's garbage. It's the same thing over there. If I don't put the stuff in a logical way back to back, it won't work. That's a logical error. So either your program runs and doesn't do what it's supposed to do, or your program fails to run because of lack of resources, which means you did not do a dynamic allocation in a pointer, but you're trying to use the pointer. There is no memory, but you're trying to use it. That's a runtime error. You're trying to write into a file that is not opened. That's a runtime error. You're trying to write on a network connection that is not made. The internet connection is lost. That's runtime error. So runtime error can happen in two different ways. Logical error, lack of resources. Are we okay down to this point? All right. And that's compilation. That's how compiler works. Okay? Now, when you are writing program in C language, you're actually using two programming languages, C or C++. One is C++, and the other one is the language with which you talk to the compiler itself. One is all the C syntax that you're writing. Another one is a syntax that you write and you talk to the compiler. You're telling to the compiler, before you begin compilation, do this and that for me. How do we write those? Do you remember? What do we start them with? Hashtag. Anything that you have that number sign in front of, it's not C programming language. You are talking to the compiler. You are telling the compiler to perform certain action before compilation begins. As a matter of fact, compiler will not start compiling until all the hashtags are eliminated. So when you actually write a program, you write include, compiler will not compile the code until that include is removed and the action of inclusion is happening. And it keeps doing that. Sometimes when you include inside that include, you have another one. It keeps doing that over and over until all the hashtags are removed. And I'll give you the example the next day you are coming in. And what is include actually? Anybody knows? When I say include, what does it do? You write include, what does it do? Literally copy and paste. Thank you. That was the first time that I got that message. Because usually people say that we are including libraries. That's not, it's literally, and I have an example in the other class that I have written. I haven't done it over here yet. We have 5 minutes. I can actually start an application, start a Visual Studio. It doesn't matter. So this is how we actually start the Visual Studio. Be careful about it. We don't, oops, that's not Visual Studio. You cannot use Visual Studio as you did in OOP345. In OOP345, you are using C++ 11 or 14 max. In here, we are using C++ 17 and later. Okay? So you cannot just start Visual Studio and compile. What you do, you create a new project, obviously. You make sure it's an empty project, C++ Windows console. That's the type of things we're going to work with. Then you go into your repository. So in here, I'm going into 2254, yada, yada, that I have over there. But in your case, you've got to go to 345 works, the one that you did, you're going to do. You don't do anything outside of it. So we are in section D. I'm going to come in section D. You can go over there into your sandbox repository. So you want to actually test stuff. Or you go to workshop 2 repository, or assignment 1 repository, whatever. Assignment 1 directory in the repository. So I'm in NDD directory in the repository. And in there, I'm going to create it. Never, ever uncheck this one unless you have multiple projects in a solution. You're not going to have it this semester. So don't. Always have that one checked. Now in here, I'm going to say A, and I'm going to say May 7th. That means A, May 7th is, I start with A and then B, and so it's sorted properly. So we know which one is coming where. And then what you do, as soon as you do that, you right-click on the project, not the solution. You go to Properties, and in here, Language Standard, you will select, I'll select that with C++ 20. Makes my life easier. And then you can now start and do this. Actually, I'll do this. I'm going to open, add, not add, open file, Explorer, there you go. So in here, I'm going to create a new text file, text document. And I'm going to call it, okay? And I'm going to copy that. And I'm going to make the other one dot ABC, okay? Yes, I'll change it. Now I'm going to open this with TextPad, and I'm going to write over here include IOStream using using namespace std int main, and that's it. Did I? IO stream. Thank you. I would have gotten our compiler anyway. So now I'm going to come over here in this huhu.txt and open that one. In here, I'm going to say cout. What the heck? Return 0 and close the curly bracket. Together, we have a complete program, right? My live compilers, please take a look. Is it correct? Include iostream using namespace the int main. And in here, I'm going to say cout what the heck, and I'm going to say return 0, right? So I have two files that they are not C++, they're nothing, right? Save, yes, save. Get out. Now in here, I'm going to come and write add, new item. In here, I'm going to create a C++ thing, and I'm going to call it prg.cpp. And in here, I'm going to say include, what was the name? What was it? He.abc. And in here, I'm going to say include, it was like, I think, huhu.txt, right? Yeah, there we go. Now I compile it. Ta-da! Include is nothing but search and replace. Sorry, copy and paste. Search and replace is define. When you write define, you search for something and replace it before compilation. So it means nothing. Compiler doesn't do any magic in here. It literally finds that file and pastes it over here, so this include is removed. Then finds that one and pastes it over here, so that include is removed. When that is removed, then one include IO stream remains, right? Then it goes, includes that one. And in that one is some hashtags. It keeps doing this until there is no hashtag. When all the hashtags are removed, we have pure C++, then it starts compiling. Okay? That's why you get weird stuff. Like when you have a problem in a header file, you get an error in your CPP file. Because it includes it and then it compiles, it doesn't get the mistake exactly where it was in your header file. It doesn't notice it until it hits something in your CPP. Then it gives you an error in the CPP where actually the real error is in the header file. So be aware of it. That brings me to the next thing, because they usually say compile time and run time. We have a pre-compile time too. That makes it a little difficult. So careful with that, and we need to know that. And that's all about how the compiler works. These are all preprocessor. They call this preprocessor directives. We have done this in OOP345 with our header files. We said, if not, define this, define that. So what we did, essentially, the compiler checks your header file to see if it's already included or not. We play a trick. And if it doesn't, if it's already compiled, it won't include the second one. It's the same thing over there. Questions? Suggestions? Objections? All right, now what I'm going to do in here, I'm going to right-click, and I'm going to say commit. And I'm going to say include. Select all, commit and push. It is on GitHub now. OK? And that's what you do over and over and over. I made a boo-boo. What was my boo-boo? I didn't pull before I started. Yeah, but it's a read-only thing, and I'm only working with it. So no excuse. I shouldn't have done that. You will see. I will do that, and I'll say, shoot, I changed that. Now I have to fix it. I'll do it. If you'll see, I'm going to make that mistake. But don't. You try not to. And as you see, many of the stuff are ignored, because I specifically, in my .git ignore, mentioned that not to bring it in. So it's not going to happen. Questions? Suggestions? Objections? All right, ladies and gents, have a beautiful day. And I will see you I think Friday, right? Friday. All right. See if you can do your workshop 0 by Friday, please. Thank you. And thank you very much for your beautiful cell phone. All right. Bye for now. Bye, everyone at home.
Bye-bye, Professor.
Bye.
Bye.
They said bye-bye.